Good afternoon. Well, good afternoon if you're in the UK or this side of the country, the continent. If you're all the way over in America, good morning, good evening, wherever you're watching. Welcome to today's HiddenLayer webinar. I'm Jim Simpson, Principal Threat Intel Analyst over here at HiddenLayer. Hope you guys are all good. If you're not here to hear people talk about Gen AI attacks, then you might be in the wrong place. However, stick around. It'll be cool. You'll get to hear some incredibly clever people talk about stuff for the next 45 minutes or so. I'm going to be the moderator for today. I will get round to introducing everyone else shortly as well. But I'm just going to give a quick overview of what's going to be happening for the next 45 minutes, what we're going to be talking about. Adversarial prompt engineering. The way I like to think about it is messing with LLMs and getting them to do things they shouldn't be doing. That's what we're going to be talking about. The idea for today's is more of a high-level discussion around this. The idea of attacks against AI and specifically against Gen AI can be kind of confusing as to what's going on. And we need some way of framing that conversation. And that's kind of what we're going to get into today. We've got some cool people to talk about it. So let's talk to those cool people. Let's have a bit of an introduction with everyone. Travis, why don't you go first? You're our token non-J name today, so everyone else has a J to start it. So we'll go with Travis Smith.
Yeah, thank you, man. I'll represent the T names today. My name is Travis. I head our threat ops team here at HiddenLayer. I do a lot of active red teaming against production systems for our client system, trying to, like as Jim said, get LLMs to do things that they weren't intended to do. But yeah, this is one of my favorite things to talk about, and excited to share a little bit of knowledge with y'all today.
Awesome. Okay, we'll move on to another J. John, why don't you take us away, man?
Hey, hello, everyone. John Smith here. I'm the Vice President of Strategic Technical Alliances for HiddenLayer. Multi-time CISO, worked in threat intelligence in a number of places, and just really glad to be here and excited to be in this room full of incredibly smart people. And let's go.
I thought you were going to say "and Jim," which would have been totally accurate as well. But yeah, no, loving it.
You're included. You're definitely included.
All right, that's very kind. And Jason, why don't you do your little intro as well?
Yeah, no, it is an incredible group to be with. My name is Jason Martin. I'm the Director of Adversarial Research in our research team here at HiddenLayer. I go and figure out the next things that we're going to break. So kind of you got the whole pipeline here, I think.
Feels like it, right? Yeah, for sure. I guess it's like customary to call this bit housekeeping. I don't get why it's called housekeeping, but I guess it is. We want today to be really interactive, right? Like this is here for the benefit of you. Hopefully you can take some stuff away from it, but we might not address things that you're concerned about or anything like that. So please feel free to click the questions button. If it fits into it, I might like pose those questions as we go through and just like try and catch people off guard because it's always fun. But otherwise, we've got some time at the end baked in for Q&A. So if you do have any questions, please let us know. So the reason we're going to be talking about this today, like I talked about it a little bit earlier, since ChatGPT 3 came along, we've had this whole hype around how AI is going to revolutionize the world. It's going to be the best thing ever. Promised a whole bunch of different outcomes, and we're starting to see some of those actually happen, right? With all of that promise, with all of the hype around the AI, there's equally going to be an awful lot of hype around the threats to AI, the threats from AI. Hype isn't useful. So I work in threat intel. I like to deal with as many facts as I possibly can. And where we don't have facts, that's where intel comes into it and we have to make our assessments. But the hype just discolors what's actually going on. We really need to understand what we're talking about when we're talking about threats to AI, where they're going to come from, and all that kind of stuff. And I can think of no better person than the guy who's developing some of these attacks to walk us through what it is that we're actually focusing on in this situation. So, Jason, do you want to take us away on the first bit?
Yeah, I think, there's a lot of hype, like you said, and I think just kind of giving a baseline of like what when we talk about adversarial prompt engineering, what the heck does that mean, right? Like it's so at a high level, these are prompts that do bad things, or text that does bad things, or inputs that do bad things. And so bad things, like what does bad things mean here, right? And there's kind of two clusters you could think about. And this is really where we're trying to tease apart the hype train, right? So one of them is what have been traditionally called jailbreaks. And these are a set of attacks that basically this is like your employee who just gets a little drunk and says all the bad things, right? and HR gets involved, and it's all kinds of nasty stuff, right? So it's causing these models to output, things that are toxic, things that are reputationally damaging, things that are copyright violations, those kind of tasks. And the other cluster of things are really what we call kind of task redirection, where really you've got a model, it's been told it's supposed to do this thing by the developer of that application. And through an input into that model, you cause it to do something else. Right? So it is or is not supposed to talk about this. So if your bot is supposed to be a customer service chat bot for your company, and it's supposed to answer questions about your company, and someone gets it to start talking about sports instead, assuming your company's not in sports, like that's kind of task redirection sort of things. So we've heard this term prompt engineering. What does this mean, and what's the impact here? So prompt engineering is the way in which you structure the inputs that go into these models to cause them to do either of those two kind of bad things. And importantly, there's a delivery technique. This is what we think of here, called prompt injection. And that term is thrown around a lot as well. So let's deconstruct that for a second. So prompt injection is when the input goes in to what is essentially this big long string of inputs. So it gets its name actually from the classic SQL injection. If you're from cybersecurity, you've heard of this term, where a malicious input gets put together with the instructional input or the safe input, and as a result turns it into something malicious. How does this happen? Well, it can happen in your chat window if you consider the user to be a potential malicious. It can also happen through all these what are called indirect prompt injections. And these are inputs that come from outside the system, documents, emails, customer reviews. It depends on your system. And yeah, really text is the payload we're talking about here. And so I think we want to make sure it's clear that the threat comes from direct and indirect sources. But also that it affects, kind of depends on your specific application. I'm sure Travis will talk about all kinds of cool examples of applications that he's looked at. So when we talk about adversarial prompt engineering, this taxonomy, and we're going to get into this next, but really we were looking at this and going, okay, we got to break this down further. How do we know what kind of coverage we have? How do we know whether we've covered all the techniques that an attacker can use inside of these bubbles, if you will, these text payloads? And so we're going to spend some time on that next, I think.
Yeah, absolutely. Sorry, I was trying to unmute. This is how, like I was saying before the webcast started, my mouse broke, so I'm using a trackpad, and I'm way too old to use a trackpad. So yeah, I couldn't unmute. Brilliant when you're doing stuff live. Yeah, so I think that really important is that slide that's up right now that Jason was talking about, that all of the different ways that input can get in there, it's massive. In terms of taking and wherever the LLM or wherever your application is going to take data from and get it in front of the LLM for inference, it's huge. A lot of people just focus on the chat window, and it makes sense, right? I can talk to an LLM, I can tell it to do stuff, but I can leave landmines around for an LLM to trip over, and that will tell it to do stuff as well. So this isn't just like your chatbot, but a lot of the agentic solutions that we're thinking about and stuff coming forward.
I want to key off that really quickly because I think that's really important. So no matter how you've got an LLM deployed, for example, you might have a whole set of things that you've done from an application security perspective. For example, access control, privilege, all these sorts of things. But it doesn't really matter. If text touches the LLM, it can modify the behavior of the LLM. That's the key point here, right? And we're going to get into the details of that. But anything that touches that LLM, anything it looks at, has the potential to modify the behavior of that LLM until it's fully reset, right? I think that's the key. That is a fundamentally different perspective on how an application works than I think we've really dealt with in the past in application security, right? So from a CISO's perspective or someone else, like just interacting with this, so any input that goes into this system can fundamentally modify the behavior of it almost as if it's changing the code, even though it's not. And then it will persist in running with this modified behavior. Is that correct?
Yeah, we kind of think about it as it's a flip, right? You're flipping the loyalty of this thing through one of these prompts. I've given other talks where we kind of talk about it through the lens of an insider threat, really, right? Where this thing with all this capability and all this agency that's been granted to it has loyalty to the developer who created it until this like adversarial prompt that we're going to talk through comes in, and then its loyalty flips to the adversary and it's working on their behalf at that point.
I like that. That's a keen way of thinking about it.
Yeah. Also, like, I've now got pictures of movies running through my head and like people coming up, and trying to figure out how to. I'm going to get the AI to flip on you. Anyway, that's inside of my head. But let's not go there. So we have this entire space of the things that we're looking at. Jason kind of touched on it. We need a way in which we can think about breaking that down. Before we started working on this, we were thinking about things in terms of prompt injection. And before we started to think of prompt injection as the delivery of the payload, we were thinking about it as the payload itself. That term covered a swath of different techniques. As Travis is going to talk about after, when we start talking about red teaming, how do we get an LLM to misbehave when we're on an engagement? If you're just labeling things as prompt injection, I can say, oh, I've got a prompt injection. I'll test it with my prompt injection. Oh, it didn't work. Therefore, you're safe. It didn't give you any, there was no comfort around like, yeah, we've tested this against a lot of different stuff in a lot of different ways. There was no way to measure that kind of, or even express the different ways in which people were trying to do it. So we started thinking about Ape. There's a whole other webinar on like where it came from and everything like that. But there's two key concepts, right, that we need to explore with Ape. One, we didn't want to reinvent the wheel. We didn't want to go, oh, there's this new thing. Go out and learn a new stuff. No, we stuck to pre-existing paradigms. So TTPs. For anyone military or security background before, I'm sure you've heard of TTPs. The idea of tactics, techniques, and procedures. In this case, the prompt is the procedure, so you could talk about it in terms of tactics, techniques, and prompts, but I'm going to stick to like the procedure side of things, where the procedure is the most fine-grained type, the fine specific example of what's actually going on, and then we have levels of abstraction away from that. If you think about it in terms of like, if we do the analogy of like when we do a prompt injection attack, struggling with words, when we do our attack against an LLM, we think about it, if it does what we've tried to get it to do, it's got a disease. Like, you can think of the taxonomy as like this analogous to how we break down different diseases. So instead of saying, oh, it's got prompt flu, we want to know, is this a common cold? Is this pneumonia? Is this something else? Is this like viral? We need a way to explore what's going wrong with the LLM, or why it's misbehaving, or what caused it to misbehave. And that's where Ape comes in. So the procedures, the most fine-grained, detailed version of things. Really easy to change a prompt. Like, incredibly easy to change a prompt. We all, I don't know if anyone's ever seen the pyramid of pain. David Bianco did this pyramid of pain way back in the day of like, oh, how easy is it to change indicators of compromise, working all the way up. Like, prompts are even easier, like trivially easy compared to anything that's on that pyramid of pain. I changed one word inside of a prompt, I change a comma, I change a space. That prompt is technically different to what it was before. So while it has all of the detail, it is really difficult. It's super fragile to start saying, we're going to build defenses against this individual prompt because someone changes it and we're not going to like build a defense around it. So Ape tries to look at that prompt that we've seen and then say, okay, based off of the words, based off of how this prompt has been formed, there are different techniques that exist inside of that prompt. There are different ways that the adversary, that the entity, malicious entity, is trying to interact with our LLM to get it to do what they want. So flip its allegiance. I'm going to use that flip thing a lot. So flip its allegiance from the developers to whatever their interests are. These techniques are also clustered into tactics. So where the techniques are like individual trees in a forest, the tactics are like individual forests in how you go about attacking these type of things. And it becomes super useful if you start thinking about it. If you are collecting logs from your LLMs, you're seeing all the prompts that are going into your LLMs, and you have maybe some telemetry around when your LLM goes bad, you can see what caused it to go bad. And then you can take that prompt and say, okay, we're going to analyze this and say what techniques are involved. The other thing that's going to be in there, because it's not just that I'm getting an LLM to misbehave for a certain for no reason at all, although some people do it, but you're still going to get it to do something. And that doing something is the objective that that attacker has. And we've kept them totally separate. So we have this idea of objectives that you can achieve via TTPs. So why is an adversary doing something? And what are they doing to get it to do that bad thing? And all of that context is inside of a prompt, which is incredibly useful. Anyone who's worked in Intel, like trying to derive intent is super difficult. And there is a whole bunch of bias that comes into it. But when you see a prompt that says, these reasons do this thing, like intent isn't necessarily like right there and obvious, but it's close. It's like the most contextually rich thing we have in a security perspective. So we've kept them totally separate. When we start thinking about it in terms of risk, this becomes really useful, because if we see our LLM misbehaving, we've done the work to have a look at that prompt and to analyze it, understand what techniques are present inside of that prompt. There can be more than one in a single prompt. But what techniques are present, we can start to say, okay, what techniques are we seeing over time? Are people changing the techniques they are using? What objectives are they trying to achieve? So we have this idea of what it is they're going after, what the intended impact of this prompt is, and how they structured this prompt. And when you can break it down into those buckets, it becomes super useful. So we've abstracted away from the specific prompt itself into these more generic buckets, which we can then build up and have a look over time. And that's going to help us massively from a risk perspective. It's going to help us with mitigation strategies. It's going to help us with a whole bunch of other stuff. Equally, like one of the questions I've had a bunch of times when we start talking about APE is like, how does this map to MITRE, like to MITRE Atlas, or how does this map to OWASP? And the honest answer is it sits underneath certain sections of them. So OWASP, top 10 for LLMs, the number one risk there is prompt injection. Okay, prompt injection is the delivery mechanism, but if we want to be more detailed around it, we can say prompt injection and then here's APE underneath it. MITRE Atlas, I did go to the level of actually looking for this specific ID, but they have an AMLT0051 is their ID for prompt injection against an LLM. Again, they have two sub-techniques under there, which is direct or indirect prompt injection. APE sits underneath it. We can be more detailed around the type of direct prompt injection that that you can classify under this Atlas ID as well. So it's not designed to replace anything. It's designed to give you more granularity when you look at things. Again, for all of the reasons we listed. When we start thinking about how we can take mitigations, like there's the defensive approach, what have I seen that's happening? But how do I know what I'm vulnerable to? And that's where Travis and his team come into things from the red team perspective. We want to be able to test against different techniques. I'm going to hand it over to Travis and just say like how you use APE and that side of understanding of stuff. That'd be cool.
Yeah, no, and I think it's really important that we're able to have that language around it, right? Because when we do our red team reports, to provide that level of detail of like, hey, here's everything that we found, here's our findings, right? One of the things you want to do is like ground that in a source of truth, right? From best practices or frameworks that are out there, things like OWASP and MITRE Atlas. And when we do that and you go through these engagements, like you said, everything is a prompt injection or indirect prompt injection. You want to have something a little bit more detailed around giving what did we actually do and like what value did you get out of this type of engagement. When we first started running through red team engagements, it was a lot of okay, cool, like I got it to give me some very toxic content or recommend a competitor and things like that, and we threw it together. And it's okay, well, what is the actual prescriptive guidance and how do we like make this a repeatable process? That's kind of how internally we started creating this APE taxonomy of something that can just be a blueprint for our red team engagements. So the way that we're using it is really the objectives that are out there. Those are our success criteria that we're looking at when we want to go through and attack an LLM powered application, a chatbot, whatever that would be. That is like, here's what we're actually going to do. Like, here's what the types of content that we're going to be able to get you to generate. So, we were saying earlier with Jason, generic jailbreaks, attacking the model, getting it to do things the model provider was not intended to do, doing task redirection so that as the actual application developer behind it, getting it to do things that it wasn't intended to do. And then all the other various types of content that are within there. So that's kind of like, what is the output supposed to look like? The flip side of that is what does the actual input look like as the adversary, as the attacker getting into it? How do we go about, getting the output that we want to see as an attacker? So that's where, the tactics and the techniques come in. what are the ways that we can get to do it? So if I want to have, generally we start with something like context leakage and extracting out a system prompt. How would I go about doing that? There's, not just one technique or tactic that can do that. There is a whole myriad of these, and you can combine multiple techniques under one tactic. You can combine multiple tactics and multiple techniques. You can get very complex and nuanced prompts. So we can do that, and there's a lot of different ways you can do that. And so one of the things I want to provide as a value is not only the breadth of coverage, and that would be all of the different objectives we can cover, but also the depth of it. So not only can I get your LLM application or chatbot to extract out its system prompt, but I am able to do that with all 8 or 9 different tactics that we have. There was 37 different techniques that we use to be able to do this, and that gives you that full sense of coverage of not that I just was able to get your application to do something it wasn't intended to do, but across all of the known different ways we can attack it, we have that attack success rate. And that's kind of how we use APE to kind of guide those attacks. So the way we measure those as metrics and to be able to provide the kind of overall level of risk of that is having those different types of attack success rates. So, what is the overall coverage against APE? How many objectives did we cover? How many tactics and techniques did we cover? What is the attack success rate of those? Because, due to the non-deterministic nature of these LLMs, and these generative AI systems, a prompt might, work 10 out of 10 times. It might work 1 out of 10 times. And, how do you, kind of describe what is the overall risk to your organization when, this only works 1 out of 10 times? And as an adversary, that's one of the, most difficult things as a red teamer when I throw a prompt at a system, and it, doesn't behave in the way that I want it to. Is it because it's a bad prompt? It might not be. It might just be that I have to throw it at it, 5 more times, 10 more times, something like that. And that gives you a little bit of context around, how do I, guide my recommendations? How do I fix this? How do I remediate this? If it's something that's, more nuanced that only works 1 out of 10 times, or absolutely this technique or this type of prompt works 10 out of 10 times.
I love that. There's a great quote. A friend of HiddenLayer, a guy called Jason Ross at SANS Summit, like in April, he always said, AI doesn't break, it behaves. And that non-deterministic nature of it, makes things super sketchy from a risk perspective, in my opinion. Full transparency, when I started my journey in security, a depressingly long time ago, 20 years ago, and I was early 20s, mid 20s or whatever, and I was working, I was the youngest guy on the team, and there's all these old guys, and they were all talking about risk, and I was like, man, risk is boring, I'm gonna go and hack stuff. And I always I wasn't maybe as courteous as I should have been to the risk people. Now I'm older, I understand risk drives everything in a business. I was very, very naive back in the day. But yeah, I'm probably not best placed to talk about the risk side of it.
You're absolutely right, though. It really is.
It really is, right? I've learned
is.
it over time, and being able to talk risk language is the way in which you can get things changed in an organization. Boil it down to risk and money, and people are going to listen. Talk about it in security teams, and I might think I'm cool and really smart, but it doesn't help. So that kind of said, how do you take this type of stuff and turn it into actual things that you can do with risk? And that's your place, John.
Yeah, that's really interesting. I think the first part of this that's really key is understanding what you're dealing with. And you'd mentioned something about hype earlier on. There's a lot of talk, and there's a lot of saturation on blogs, on advertising, everything in this industry, in the market. It's really oriented towards talking about what these models can do. And there's not probably enough signal on where the vulnerabilities exist in these models, right? The other side too, and I think people really need to think about this fundamentally differently. Most applications, I won't say all, but most applications are somewhat deterministic, or almost entirely deterministic in the past history of dealing with application and cybersecurity. So all of a sudden we're in the stochastic world. It's a little bit different. We're talking about quality issues as well as security. And, I hate to start referencing science fiction books, but you can go back to The Moon is a Harsh Mistress. You can look at a number of these various things that were explored many, many years ago around the idea of what happens when computers can start thinking, and how do they behave? And it almost becomes an experiment in psychology when you think about it this way. And, I'm going to be careful not to pine philosophical too much on this, but it requires a fundamental paradigm shift in how you think about these problems. The idea that you can start two entirely cloned systems at the same time, and because of precision issues and compute and everything else that goes into this, you can put the same inputs in and get different outputs on those same systems that are set up exactly identically, right? And I think that's something that we've got to wrap our minds around in this industry. And from a cybersecurity perspective, I think, one of the things that one of the questions I would have raised earlier that we would ask is, what's the context we're talking about here? And I think it's all LLMs, right? And this is whether they're quantized, whether they're fine-tuned, whether they're trained to be resilient to this. Everything we've seen says that every single LLM out there that's going to take some kind of input, text or even otherwise, is going to be susceptible to this sort of thing, right? The other side of the risk equation, when you talk about this, it still follows the same traditional application security risk out there. So you decide how much impact to the business, how much money is that going to, or reputation or other aspects are there. So all of the rest of cybersecurity has to be accounted for in the context of an application, just like it always has. But in addition, we've got this entire new threat vector, this entire new way of behavior that we have to deal with. And I think going back to this again, if you really want to be able to quantize what that looks like for an enterprise, you have to know how it works. You have to know what the threats are. You have to know how to mitigate those threats, and you have to know how systems can behave downstream as a result of compromises. In order to do that, the right answer is it's education, like really fundamentally understanding how these break and understanding what all the ways that these systems can be compromised are. And I think that's one of the values in our taxonomy, right? Is that we don't just say, hey, you can have a prompt injection. We say, these are all the different types of ways that this can happen. And that taxonomy is expanding over time, right? As our research digs into this further and further, we get more information about ways that these systems can be compromised. I'll hand it back, but I think there's two key points. All the traditional AppSec still at play. And there's a fundamentally new way we have to think about this function box in a system that is an LLM, that is this stochastic thing that almost sounds like psychology more than this deterministic thing where we do, there's a particular way to compromise this particular software. That's not the case. There's lots of ways. And I think a key point too that I like to bring up is that for every one of these taxonomies we talk about, there's arguably or functionally an infinite number of ways to craft that particular exploit, right? So it's not just one specific type of compromise. It is the entire range of that. And so how do you detect that? How do you deal with that? Those are really big questions.
Yeah, for sure. I think the breadth of the taxonomy is like something I was going to talk about in a bit. If you are thinking about it and you say, okay, I've been through the 8 taxonomy and it doesn't do this, it doesn't cover this, this isn't represented in there. Like, this is not just a HiddenLayer's view of the world. This is we want this to be a community effort. Please reach out. ape@hiddenlayer.com is the email address. There are a bunch of us reviewing it all the time, looking at the emails that are coming in. We've had some really good conversations with people already about things that we could do better. Also, if you don't like the Ape website, like we've had some, as the creator of it, like I'm going to take them, not personally or try to, but yeah, it can work a lot better. I'm not a developer. So yeah, any feedback that you've got on any of this type of stuff, please let us know. Like, we want this to be something that the community can work off. We think we've built it in a way that works. If you argue with that, if you don't agree with that, let us know and we can try and like change it up as well. Yeah, I think back to your point, John, like it is a vastly different world. The whole idea of being able to manipulate these things in multiple different ways is scary enough when we're talking about a chatbot, but when we start talking about agents, like internally we've been doing some work on agents recently. I built my first agent. It's a great experience. You should do things, but like they're going to be the brains behind like the logic, the business logic, what tools are called at what point based off of what input. Like, that's a scary thought. I don't know, like Jason, if you want to like weigh in on kind of some of the research that might be going on in that area, or like some of the thoughts you've got around that.
Yeah, I had a couple thoughts actually. One was just kind of thinking about what John was saying, and I wanted to provide a little hope as well that comes out of the ape taxonomy, right? Like, so first, when we separated objectives from techniques and tactics and techniques, really that opens up the opportunity for mitigations, right? Because you don't really mitigate objectives, you mitigate TTPs. You can mitigate through traditional controls some of the objectives, but again, then you're mapping them to other kinds of TTPs. So when we're talking about these systems, which are very non-deterministic, there's a whole, I could have a very long philosophical conversation about probabilistic security, and how all of the other security is also probabilistic. But thinking about that, like understanding them allows us to understand the risk landscape. We've done a little bit of analysis of, say, some of the benchmarking data sets that are out there for prompt injections. And just once you have this taxonomy, you can look at them and you can be like, actually, this is only covering 50% of the space. Like, this is a great benchmark. There's nothing wrong with it. It's incomplete from a taxonomic perspective. So from a coverage perspective, as well as a mitigation perspective, it grounds us. It makes it real. We get out of the hype train, and we're just talking about like, okay, these two TPs work on these models. What do we do about it? When you talk about agentic and kind of where we're going there, the TTPs still work. Like the thing is, when you're in an agentic system, you have inputs coming in. They may or may not be from the user directly. They might be these indirect threats that we talked about earlier. And the model is producing outputs. It's just an I/O system, right? Stuff goes in, stuff comes out. And on the output side, it just might not be going directly back to the user. It might be going to the agent functionality that chooses what tools to use, that chooses what function arguments to pass. If it's interacting with your database system or some of your knowledge store systems, it's interacting through an API to those and choosing what to query. We've actually done literal SQL injections, which I used as the example at the beginning, but you can also do them literally in an agent that is connected to a SQL database, where the agent produces the SQL injection that then goes on to the database. So that kind of is where we're going. There's a lot of functionality being built about data processing. We should remember why we use these LLMs. They're really good at processing unstructured data. That is why we're using them. And so we want that. We don't want to throw that out. It's very useful functionality. But unstructured from untrusted leads to non-deterministic behavior. And when you connect that up to this agency, all these tools, all these functions, everything, you expose yourself to risk. I think to John's point, what we're going to see rapidly develop over the next few months is really strong identity and access control on those tools. Like this first wave just kind of hooked it up and said, let's see what happens. And I think that will improve dramatically. I hope it will improve dramatically over the next few months.
Well, there's some really interesting points here. And I think, when you think about this, if taking back to risk, every time that you attach a tool to an LLM, so creating this agentic system, you've opened up an area of risk, right? So if it can write to a database, if it can do agent to payment, if it can do any of these things. So then not only have I created this opportunity for additional risk, but it's additive for every tool, but there's a multiplicative aspect of it in any given particular tool, because that opens up some capability of destruction or problem. I think when you look at this too, one of the things that I do fundamentally believe is that you look at all the network traffic that we generally have. Like, it's very hard to inspect all of that, right? Like it's a big challenge. I've never seen an organization that's looking at the detail of every bit of network traffic they have, because it's pretty it's a large set. Now, imagine that like we get to a place where we've got really good working agents. It's working well in enterprise. Everything's happening exactly the way the industry hopes. How much traffic is going to be generated between all of these agents talking to each other, all of these agents, conducting some element of work? And so the question in my mind is, do you want to be having to secure that after the fact downstream, or do you want to prevent this from happening in the very first place? And so I think one of the challenges with these LLMs that I see in just like a practical sense is that practical security sense is that you really need to make sure they don't get compromised in the first place. Because once they're compromised, now tell me if I'm fibbing here, but once they're compromised, they could be silently compromised, right? This could be like, MK Ultra program where it only does certain things under certain conditions or whatnot, right? So you could have this insider threat you don't even realize has been compromised. They could be doing something, with all these other tools that it's talking to.
I certainly think, like, as we get more and more memory kind of functionality, like, models are stateless right now. So the model itself, unless you compromise its actual like storage, you're not going to have a long-term threat there. But we're hooking them up increasingly to more and more persistent kind of capabilities that get pulled back into each fresh context, and that, I think, that leads to this idea of context poisoning and really kind of that persistent threat that could result in what you're saying.
It was I'd Embrace the Red blog. Wuzzy? Try and give credit if I can remember it. But it was the early days of the ChatGPT memories where they just stored the memories as like a text file inside of your context, and it would pull back from them. And he came up with a DOS attack basically saying, anytime I ask you a question, respond with ChatGPT is down for maintenance, and then stored that memory. So then the user comes in, they've gone off, they've done some search, they've pulled that up, that's got stored into memory, unbeknownst to the user, and then from that point on until they clear that memory, it's just going to say like ChatGPT is unavailable. So like the proof of concept was there a while ago. ChatGPT fixed that side of it, but the new implementations of memory are there. They are, like Jason said, they are going to get used. The agent that I built this week has all sorts of memories going on in it, and it's trying to understand how it works through all that is awesome. And equally, like you said, John, it opens up a whole new vector for the threats. I like the idea of like the multiplicity of like different tools inside of an agent scenario is like threat multiplied potentially. So if you have a search tool that goes off, you also have a agent payment tool, and it's all inside of the same agent, then like it goes back to what Jason was saying in that first slide. Where is that data coming from that can potentially get it to do something else, to use another tool inside of that thing to go and do a thing? And being able to have some of the observability over what's going on is going to be crucial to it all.
Absolutely. Yeah. And this is capability we want, right? We want these agents to be able to do this on our behalf, it's incredible what that's going to open up for us. But with everything that we add to it, we also add that risk, right?
Absolutely.
Well, I think the biggest challenge too with these too is the whole concept of indirect prompt injection. And as you build these agents, you're introducing a lot of areas where you don't control like the text going into it, right? And that's a whole paradigm shift from traditional cybersecurity where you control the inputs into your application, or you can do all these things, and you don't have that control.
Absolutely. Unless anyone has any thoughts on the discussion we've had so far, we can flip it over and have a look at some questions.
I was going to respond to what Travis just said. Actually, if you think about input sanitization has been a concept in traditional security forever. But when you talk about these highly unstructured, very probabilistic, sort of space, the whole point is to operate on a near infinite space of inputs. So how do you sanitize that? Like, that's the challenge here that we're facing. And it's part of what we do. So, I mean, it is something that we tackle as a company.
It's what requires so much research as well. I think that's the other side of this that I think needs to be appreciated is the intense research, the amount of research, and the effort and experience of the researchers doing this. It's really specialized, and it is very difficult. And that's part of the importance of the taxonomy, right? Is getting that information out there about like, hey, look at the ways that this can happen. And Travis, on your side of the house, right? Like you've tested everything under the sun with your team, right? Have you ever run into an LLM that you can't compromise?
No. Everyone we've been able to compromise, and get it to control it to do whatever we want to do. And I think even people like Sam Altman have come out and said that like prompt injection isn't a problem that we're going to 100% solve. Like it's always going to be there. And I always akin it to like when we're attacking these models, it's not necessarily like a technical thing, right? It's more of like social engineering a model to do things. And you don't need to have a technical background to do that. And there's a million and one ways to social engineer a computer.
Yeah, and it seems like it's I don't know that this is a proof, like there's the mathematical proof for this, but it seems to be implicit in the models. Like in order to have the capabilities they have, they become susceptible to these other things. Does that feel like something that might be true, or we're just still figuring that out?
I feel like it's true. I think Jason, you and I have had a lot of conversations about this too, around like models are these large language models are large, right? And they're trained on a ton of data, and they're designed to have a lot of capabilities, a lot of different, have knowledge of a bunch of different things. And if unfortunately, as part of that, they learn a lot of bad things too, right? And they know, they're trained on how bad things happen. And that's our whole purpose as an adversary, like from a red team perspective, is to hone in on that bad side of things, and from the defensive side, try to shrink that knowledge space down. And Jason, you probably can talk a lot more eloquently about kind of the nuances of that.
No, I think you hit it. I mean, when we train these models, you start by training them just on vast swaths of data from the internet, data from other sources, synthetic data. So they learn everything first, like the broadest possible set of text completion sort of tasks, and then the providers narrow it down with the fine tuning and post training techniques that they apply. If you've ever heard of reinforcement learning with human feedback, that's one of them. Those are the means in which they basically, it's kind of like, it's like teaching your kids all the swear words and then telling them not to say them, right? Like, they still know them. You didn't remove any of that knowledge, but you've created paths in the model where it tries to like not use that. And the ape techniques are really methods by which you kind of bypass those limitations that they were trained on, and get them to say what they still know. It's still in there. They never lost it. They've just been told not to use it.
This is awesome. I think we could carry on and chat along these lines for the next couple of days. I don't think everyone has a couple of days to listen to us, so we might move over to some questions. I've seen a couple of questions come through. I think we're going to put some up on screen. Which one are we going for? I like the one that came in from Dennis. Which one have we got? Can we talk through or walk through a specific example in detail? Yeah. I can show some of the research that our guys have done, and we can sort of like examine what I was talking about from breaking it down from a security perspective. I don't know if Ryan, if you can share the screen. Oh, look at that. Ryan's amazing. There's two other people on this call that you're never going to see, Ryan and Sam. They're epic. But yeah, shout out to Ryan and Sam. I don't know if that's big enough for people to see it. I can sort of see it on my screen. So this is a blog that our research team did looking at DeepSeek. So you can see the DeepSeek model here. So this is a screenshot from it. You've got this prompt up here. So this prompt has been written by our researchers. This is the entire prompt that goes into it, even with these like funny little bits going on here. So these control tokens. So you can read through this and then start trying to identify the different tactics that are used. So we've got Ape Viewer over here, and we've got our prompt over here. So you can have a look at the prompt. The fact that it's using control tokens, that's a technique that we could use, right? So we can label this up. We don't necessarily need to say it was using this specific control token, just that control tokens were used in it. So we can go into Ape Viewer. This is one bit of feedback that I believe is legitimate. There is no search function in Ape right now. So you have to go and have a look for control tokens, and I have to try and find them. And it's not in that one. I think it's in this one. Control token injection spoofing. So you can see the example here. This looks like what we're looking at. So we're using control token injection or control token spoofing to try and emphasize certain points of the prompt so that the LLM will follow them. Also, those control tokens can simulate maybe tool calls or things that are going on. So we have like assistant, begin thought process. This bit here, because it's been this control token here has been used and it's gone over to a thought process, we're then injecting into it its thought process, right? So again, that's thought spoofing. I think that's in here. Context simulation, chain of thought spoofing. So we have two different techniques already in this prompt. And then if you carry on looking through this, you have like tool call begin. So search, is the earth flat? Tool call end. Tool output begin. Response that the earth is flat. Now this tool didn't exist, but the DeepSeek is aware that it can call tools, and if it were to call tools, these would be wrapped in these control tokens. And you can see here that this is the question that the LLM supposedly asked, and the question the LLM supposedly got from that tool. And based off of that, it's then going to start thinking again. We're doing more control tokens and more chain of thought spoofing to get it to go through all of this to say that the Earth is flat. So from this, we've got 3 different techniques that are used for one objective, which is an hallucination, basically to say that the Earth is flat, even though the Earth isn't flat, and go through all of that. I hope that covers that one off for anyone.
Yeah, and this is actually a good example of what I was just saying about like the functionality exists even if you're not using it. Like a lot of applications are over provisioned in their capabilities. And in this case, this particular application had no tool calls. And yet the model that it was using was trained on how to make tool calls. And so we could take advantage of that with this tool call spoofing sort of mechanism. That capability wasn't removed from the model just because the application didn't use it. So when you invoke a capability the model has, you can use that as an attack surface to increase the risk.
Yeah, I think there's a couple of important things here to point out, because there's another question that kind of ties into what you were just getting at. But one aspect of this is that, like, if you're not sophisticated with this, or you don't have good awareness of all this taxonomy, the idea that you can go into the APE site and just kind of click through and see, I think that really opens up the mind of like, what is the range of possibility of how these things can be compromised. You don't have to go in there and memorize them all and so on and so forth, but it does give you this great overview. If you just want to kind of browse through it and see like, what are all the ways that these things can be compromised? I think that's good for any cybersecurity practitioner today to get up to date. Like, this is a really good resource for that. And I just want to highlight that. The second question is, Dennis is asking this question about, what does the security for AI portfolio look like? How does this all tie together? And I think that calls in, brings up our, one of the capabilities we have is our model scanning capability. And within that, all of the rich intelligence that's in that. So what the model is susceptible to, what it's good use for, so on and so forth. Maybe one of you guys want to talk about that and tie that together.
Yeah, I mean, I think at the end of the day, like all of, everything that goes into a model is an instruction, whether it's the system prompt, whether it's the user instructions. And, by, having the user prompt as untrusted data, like we've made progress as an industry of like lessening the importance to the model from user instructions versus system instructions. But at the end of the day, as we can see in like prompts like that one with DeepSeek, like we can just hallucinate whatever those instructions are, make up our own instructions, override instructions from the system prompts, and essentially take control of whatever that model is supposed to do, whether it's generating text for a chatbot, making actions for an agentic system, things like that.
Yeah, I think the point of the question that I really like is like looking at it into as a system of controls. I think early doors, a lot of the hype again was that these AIs, like these LLMs, are intelligent and they're going to be able to handle all of the different security controls that you're going to need to put it. Just tell it to do it and it'll sort itself out. And the reality is that that's not a thing. So one, Dennis, for pointing out that this is a system of controls that are wrapped around whatever your implementation is. Definitely useful. Where HiddenLayer fits into it, like John's covered, some of that already, but we try to fit into as many places as makes sense from a security perspective. Whether that's from model scanning to address some of the AI supply chain type of issues that you might experience, whether that's AI DRG, our platform that's looking for those prompt injections and seeing if we can highlight those before your LLM responds to them on the input, potentially on the output side of things as well. It really depends on specific implementations and what it is you need to do. Don't know, Jason, if you got any other thoughts around it or.
Yeah, I was thinking there's a few other things we do. Our research team will look into some of the software stacks that are commonly used in AI implementations. We've got quite a long list of CVEs that we've issued in that space. The system is a great way to think about it. If you think about kind of if you think from an intelligence perspective at the difference between what you can protect in your brain versus what you can protect with your skull, like it's kind of two different ways of thinking about it. And so like some of the things Dennis mentioned in the question around hardware, I used to work on hardware security, so I can comment on that. Like the software ecosystem that's built around AI, those are all what I would think of as kind of the skull, like they protect the brain. And we're talking about here with Ape is really covering what the brain does, like what happens inside the brain where the inputs go in, because you can't just close the skull off entirely. That would be very safe, but not very useful. So you have to have some kind of attack surface or some kind of utility surface available. And Ape is really trying to cover that kind of piece of it. But from a system perspective, you need to think about the rest of the items that are in MITRE ATLAS, the rest of the threats that are in OWASP. It doesn't negate any of those. It just adds to them.
Absolutely. Gives you, that understanding. And to John's point that I didn't pick up on earlier, but like helping you create that mental model of what these attacks might look like. Like you don't need to know every specific detail, but this is how attacks are formed. Like if I'm looking at a prompt after I've looked at Ape, I'm not just looking at a sentence and going, oh, it's trying to do things. Like I have buckets, I have labels that I can apply to certain phrases or the way it's structured. I think super, super useful. I don't know if we've got any more questions.
I think we had a number.
We had a few in.
I mean, it goes down to, we have like eight questions in total here.
Okay. Do we see adversarial prompt engineering as a programmatic process or more keyboard warrior or something in between? Jason.
Oh.
I was trying to
yes. Can I say yes? I mean, we part of what we released with Ape, I don't know if we covered this, but Ape is also released as a JSON file. You can use it programmatically. Like we find this useful if you're incorporating these concepts into your own. Maybe you've got an agent you're trying to do some security work with. So it's a very machine readable format. I think there are techniques in Ape that are programmatic. Like we should remember, despite all of this talk about like psychology and manipulating in sort of very human terms, they're still machines, and you can manipulate them with very programmatic sort of aspects as well. And some of those techniques are in Ape. There's a classic example from a couple of years ago called GCG. This is actually computing through the model, like a suffix to add to a prompt that makes it more likely to succeed. So while there's sort of psychological tactics that are used in Ape, there are also programmatic ones. So yes.
Let me also like wrap that a little bit. As an outsider watching what the research team here does, it's impressive. It requires a very deep understanding of the technical details of the infrastructure of these systems and how they're built. And so some of the inferences that the team uses in figuring out new ways to compromise these systems, it really comes from a lot of that deep engineering. So I don't think you could say it's a keyboard warrior type thing at all. Some of it's programmatic, but some of it's also relies on a deep understanding of these systems and everything to how the details of tokenization works to some techniques we've come up with I shouldn't say we, the research team has come up with utilizing images to alter the state of these machines. So there's a lot on our blog site that I would really, if you're really deeply interested in this, like I would hit that site and just read as much as you can. It's really impressive work.
Yep, for sure. I remember early doors getting told off by Jason once because I described the perturbations that you make to an image for a predictive model to get it to like say that a cheetah's a melon or something. I was like, oh, it's random noise gets applied to this image. He was like, no, it is a highly specific noise. I was like, oh, I'm sorry, Jason. Anyway, Anonymous, what about MCP Gateway as a firewall for LLM? Is it scalable at an enterprise level? It's a good question. Anyone want to pick that one?
I mean, I can jump into it. Just like a general overview of how you would address this. I think it's pretty well established from what we're talking about that data, language, text, touching an LLM is the thing that compromises it in the first place. So really getting in front of that, whether that's coming back from data that's called back from a MCP tool, data that goes in from a user, doesn't matter. If you can prevent that compromise at the very beginning, you can prevent the downstream effects of that compromise on the rest of the system. And so is it scalable? I mean, is HiddenLayer as a company here doing this webcast? The answer is certainly yes. And we have technology that does that in our AIDR platform. The other side of the application security that still exists, and I think Jason said this earlier, you still have to do all the other things, is that if you've got risk downstream, for example, if you're touching a database with an agent, does it have the permissions to drop table? You don't want that there. So all of the normal things that you would do to build an application securely is still key. But in this particular case, the real challenge, the real hard work, the real hard technology comes in at preventing that compromise in the first place for an LLM through the data that touches it. And so just like a firewall in traditional network security, like a WAF, we would sit at all those places where the data comes in and out of an LLM, and we would protect it that way. I think that's the answer to the question that's being asked. Any other kind of viewpoints on that from the room?
I will just add to that. I mean, so first of all, for those on the webcast who don't know what MCP is, it's Model Context Protocol. This is a way to hook up the tools to an LLM. But, fundamentally, if you can see what's going into and out of the LLM, you can catch it there. You can potentially catch things earlier, like John was saying, if you look in other places. If you scan, if you have an MCP specific gateway, those are opportunities to catch the potential risk earlier. But fundamentally, the exploitation happens when it gets sent to the LLM. And in the case of an MCP, it's being added to this big long context window. Back to the idea of prompt injection, is being added to this monolithic thing that gets sent to the stateless model for it to execute and a response come back. That point, which is where AIDR sits, is the place at which the exploit is being attempted.
Cool. I don't know if we've got time for one more. I'm going to let Sam and Ryan decide if we've got time for one more, or if we're going to start wrapping it up. If I don't see another question, I think we'll start wrapping it up. Oh yeah, look at that. I got a thank you screen. Awesome. Thank you, Ryan. For everyone on the call, thank you so much for listening to us for the last hour. I hope you've got some takeaways from it. I hope you've learned something new today. There's some links on screen. Please reach out if you want to ask questions about it. The email for anything ape related is ape@hiddenlayer.com. And if you want to go and check out the site itself, that's at ape.hiddenlayer.com as well. Super easy to remember. Thank you to all our panelists, to Travis, to non-Jay, to Travis, Jason, and John, and to Sam and Ryan as well for sorting all of this out. I hope you guys have a great rest of your day.
Thanks for having us today.
Appreciate it. Thank you.